complex rational expressions. As you see in the example 2a, we have the numerator as the difference of a over b and b over a, all divided by the quantity a plus b. It is called complex rational expression because there is at least one rational form within the rational form. And sometimes for the numbers, we call the complex fraction. And to simplify, we are going to rewrite the expression in the convenient form that we can manage or look for the common factors to reduce it eventually. In this case, we have the long division bar that represents the division of the two quantity, and we write this as the quantity of a over b minus b over a divided by the quantity a plus b. And after that, we are going to simplify the difference of the a over b and b over a by looking for the common denominator, which is a times b. To combine them, we have to make them the same, make two terms to have the same denominator. Therefore, we're going to multiply the first fraction by a over a, the second fraction by b over b. That results the numerator of the front term as a times a, which is a squared, minus b times b, which is b squared, divided by the quantity a plus b. And then we are going to rewrite the division into the multiplication of the reciprocal, or we can see a plus b as a plus b over 1. Then we have a squared minus b squared, all divided by ab times 1 over a plus b. Make sure we put parentheses around. And then the next part, we look at the a squared minus b squared, and actually this is the difference of the two squares. And it can be factored to be a minus b times a plus b, which is the product of the sum and the difference. So we can rewrite it as a minus b times a plus b, all divided by a times b, and then multiply by 1 over the quantity a plus b. After that, you can see the common factor that we can reduce, a plus b, a plus b. That gives us the simplified form of this complex rational expression as the numerator a minus b divided by the denominator a times b. Let's take a look at another problem involving the complex rational expression. We are going to simplify the quantity 9z over 7 minus 7 over 9z divided by the quantity 9 minus 7 over z. We're going to start with identify the portion of the numerator and denominator and rewrite it in another form. The numerator part, 9z over 7 minus 7 over 9z divided by the denominator quantity, which is 9 minus 7 over z. And then we're going to simplify each quantity using the common denominator, 7 and 9z. The common denominator will be 7 times 9 times z, or 63 times z. So to combine them, we're gonna make the first expression and the second, the first rational and the second rational to have the same denominator. So it's gonna multiply the first one by 9 times z over 9 times z, and the second rational at 7 over 7. Therefore, the first term becomes 81 times z to the second one becomes 49, and then similar to the second quantity, the common denominator, which is the common factor of the z and 1, common denominator, sorry, gonna be z, or z times 1. So we're gonna multiply the number 9 with the z over z we get 9 times z minus 7. As we have the quantity divided by another quantity, we are going to rewrite this or rewrite the division into the multiplication. Now we get 81 z to the second minus 49, all divided by 63 times z, multiplied by the reciprocal of the denominator, or the reciprocal of the 9z minus 7 over z, which is z over 9z minus 7. And I'm going to put the parentheses around to make sure that we treat them as a group. At this point, we can see that the z and z can be reduced, and the 81z squared minus 49, it is the difference of two squares, which is 9z quantity squared minus 7 quantity squared. That is one of the special product, or it's called the difference of two squares, and it can be factored as the product of the sum and the difference of the first term, which is 9z, and the second term, which is 7. So then the numerator part can be factored as 9z plus 7 times 9z minus 7, all divided by 63, multiplied by 1 over the quantity 9z minus 7. Then we can reduce further as we see the quantity 9z minus 7, 9z minus 7. Therefore, this expression is simplified to be 9 times z plus 7, all divided by 63.